any language. And yeah, let's just see how many we can do within an hour. Yep. So, oh wow, that's fast. Within the first 15 seconds, we have a clash already. Yes, let's go. So, reverse mode. Right. So, I will use Python, I guess. All right. So, this is test. I have spaces. I guess we need to split the input by space and then like maybe convert this to binary. Like this could be like 0 1 1 1 0 1 0 0. Okay, let's just convert this to binary first. So for each input dot split in this one dot split. Okay, we convert this into binary by just looping through this each. Okay, so maybe we could just do something like um, power equals to 1. Okay, for I in range length each. Okay, okay, then we need a sum also. Okay, total equals 0. Okay, total plus equals to, so if it's a plus then we'll put s2. If it's a, okay, so here will be if each I equals to plus. Okay, so actually we should make the power become like 1 to 8 maybe. 1 2 3 4 5 6 2 the power base 1 to 8. Total plus equals to power. Okay, it's like converting binary. Then power divided by equals to 2. Okay, print. Okay, so we have a string here also. Maybe s equals like that. So s plus equals to character total. uh, maybe it's like that. So let's just see whether it works. I'm not too sure. Okay, so integer argument expected got float. Okay, so this needs to be a floor divide for it to be integer. Oh, great. So it's really converting it to ASCII and then like converting it to binary and then use ASCII to do it. Oh, wow. Didn't expect to solve it on the first try, but yeah. Converting the plus and minus to a binary bit, and then from binary bits convert into decimal, and decimal you convert into ASCII characters. Interesting clash. Okay, let's try again. Let's try again. Yeah, if you have any requests of any language you'd like to see, you can just put in the chat. If I know it, I'll code in that language. If not, it will be fastest language first, which will most likely be Python. Yeah, I mean, I tried using JavaScript, still not very used to it. Maybe I can try using JavaScript for the next question. I'm flexible actually with the language. Shortest, more output, the shortest have to be Ruby. Smallest prime factor of n. So it's like this 3 times 5. Oh, that's easy, I guess. Okay, so we have a get s to I. Okay, so maybe we start from 1 to get s to I dot each. Okay, maybe we start with 2. Okay, if this can be divided, so maybe what we do is we'll do a map. Okay, dot filter uh, divided by 2. Oh, no, what am I doing? So we firstly need to do this as a variable like that. Okay, so from 2 to n, we filter only the numbers that n percent 2 greater than smaller than 1. N percent, this one smaller than. I wonder if I can do that. All right, let's just print this to see whether we can do it. Yeah, so this should print out all the factors that can divide the number. Okay, then we just need to just take the minimum. Oh, okay. So zero is nil. Zero is a special case. If n equals to 0 or 1, you must output none. Mm, I guess I need to do an if statement here. Let's see how best to do this. If it's nil, then I need to do none. Okay, so maybe I store this as x. Okay. Okay, we print none. Wow, that's really short. Wow, 28. Yeah, I guess I'm doing a bit too much here. Yeah, I mean, a way to do it is prime factorization in Ruby. There's a prime there's a prime factorization inbuilt function already. So we could just ask like prime question mark. Yeah, or we could do prime division. Yeah, but 28 is really very short. Later I'll take a look at the code if he shares the code. Yeah, it's really quite impressive. So okay, let's do this. Okay, so I guess what I'll do is I'll just print x dot nil. If it's none, if it's nil, there is none. If not, it'll be x. Okay, I'll need another question mark here because x dot nil is unexpected and offline. Maybe I need a space. Okay, I need a space after this question mark then. Yeah. Okay, so this looks good already. That's 61 characters. Wow, 28 characters. Wow. Yeah, I'm happy with this. I'm just gonna submit this. I think 61 characters is not too bad. Let's take a look at his code. Oh, factor. Oh, what's this? Factor bash command. Oh, nice. You can print the prime factors with factor. And then if let's say there's nothing, or if this one is a zero, then it'll be all with a text none. Oh, very good. I think I followed Adrian. Yeah, follow. That's really very efficient. Yeah, I was thinking how on earth you could do 22 characters, and yeah, turns out that's how you do it using a bash command, factor. Interesting. Next time I'll know. Yeah, it's quite interesting how Ruby can incorporate bash commands, and you can just use the best of both worlds because of that. Shortest mode. Yeah, studying for spelling bee, can't seem to remember how Greek and Latin origins impact spelling of a word. Help him model it with a program. A letter may sound like K, but always spell with C. Sound like S, but spell with SC. Okay. So you only change the SC, you don't change the S. Looks like only this one will be. Looks like only this one is the special case. So this Latin, you change this to Greek. So if Latin, that means I change K to C, right? K to CH, K to C. So if the origin is Latin, K to C. Yeah, I guess this is fine. Origin and word can be this equals to get s dot split. We don't need this thing here because it will already be split the space if we do this. And then after that, we see whether it's Latin or Greek. So if it's a Latin, mm, okay, so if it's Latin, else, and okay, not very efficient here, but I'll edit it later, I guess. Yeah. So if it's Latin, then we need to do this transition. So w dot s but spelled with sc. I guess I'll have to use the g sub command. Yeah, maybe I'll just like let's print this g sub k with a c. Okay, so here the s will be a special thing because we need to check whether there's no c in front. Regex look ahead. Yeah, so I need to use a regex look ahead here because we don't want to sub in those with c. Where's the look ahead? This is a look behind. Uh, look behind. Regex look ahead. Yeah, let's try to find an example for regex look ahead. Positive look ahead. Question mark equals negative. We want the negative look ahead. Yeah, the negative look ahead cannot contain c. Then we'll sub it with sc. Let's just try the Latin one. Let's just try this. Yeah. So here is sub. Okay, so here we can do the same thing. G sub I with y. G sub f with ph. Dot g sub k with ch. Okay, very nice. Okay, so I guess this is it already. Okay, I'm just thinking whether we want to do Ruby trace translate method. Yeah, because the translate method might be able to translate more characters at one go. So yeah, we could just do translate, I guess. A to Z, A Z. Oh, but translate cannot really handle like stuff with two characters. Hmm. Okay, so over here, I guess what we can do is we can shorten this. We can check whether this is an L. If it is, then we print this. If not, we print this. Yeah, okay. I think that's more or less it. Yeah. Yeah, just in one line using G sub. It's not too bad. Oh, there's a lot of people today. Interesting. Looks like weekend everyone is coding Clash of Code. Hello true, water force. Happen true, hitchhiker true. Okay, I need to find a pattern here. So what's the pattern? I see the force. Water is force. Galaxy is force. Oh, is it two consecutive letters? Repeated letters. Yeah, repeated letters. So get s dot charm. Okay, I can use Python for this. Okay, word dot input dot lower. Okay, we want to make it all lowercase. Okay, then we just want to count whether there's a repeated letter. All right. So in order to check whether there's a repeated letter for letter in word, okay, if word dot count letter greater than one, okay, so repeated will be false by default. Okay, so if it's greater than one, then repeated will be equals to true. I just need to print uh, true, comma false based on whether it's repeated. Yeah, okay, this means that if repeated is true, then it will be true. Okay, actually this should be like that. Because in a boolean, Python interprets boolean positive to be one and boolean negative to be zero. So you can reference the index here. Okay, let's try. I think this is going to be correct. Okay, test 5 failed. Oh, looks like the repeated letter must be next to each other in order for it to count. So for I in range length word minus 1, if I equals, okay, if word I is the same as word I plus 1, then repeated equals to true. Okay, let's try again. Yeah, it must be consecutive words. Okay, yeah, that was a good clash. And look, boy, look at how fast they coded it. Nice. This is just using regex to just find whether there is or not. And then print not word dot uppercase. Okay, which means that whether it's true or not, and then you not again, which, which means false. Yeah, so first one is to do the check for nil. Okay, if it's nil, then this will be not, this will be true. So then, yeah, that's an interesting syntax. Yeah, same thing. They, what does gi dot test do? Okay, so this is the regex pattern. Okay, and then you test it on the word. So let's check JavaScript regex test. Execute a search for match. Okay, returns true or false. Very nice. Yeah, so straight away returns true and false already. Oh, these people are good. Today's clash, people are quite good. Two integers a and b, operator op. Write the expression and its evaluation in vertical format. Oh, that's they already split for me here already, so that's easy. So AB is 1 to the power 6. So I will need to, the length of line depends on the longest lines. Okay, so let's just do C equals to eval A eval inputs. Okay, let's just print ABC and see whether it works already. Eval must be a string, bytes, or code object. So let's have the original expression as x. Okay, x dot split. Okay, so we eval x over here. So yeah, with eval, it will already evaluate the operation. Okay, so the length of the string will be having a plus over here. So uh, okay, so max length will be equals to max a Okay, how do I test length for string? So we need to convert all of them to strings. Yeah, I mean, looks like I don't have to. Yeah, maybe we just do this. We convert all of them to strings and then we find the max length. That will be okay. Then we just print max length to just test it out. Yeah, max length is 3. So what we do is we print a dot r just max length plus 1. I think r just, if I'm not wrong, it right justifies the word itself such that the length and the character to pad. Yeah, so if we adjust it, it will go all the way to the right and we will be padded. It's either adjust or left just. So let's just try this. Okay, B. So over here we not just want B, we also want the operator over here. Okay, and then here we want C. So let's check this out. Invalid syntax, not a function. I miss out the close brackets for each of them. Okay, let's see. Int object has no adjust. Yeah, so yeah, looks like we need to do this. Yeah, let's see whether it works. So that was 3 over here, so 3 needs to be taken away. So over here we also need to print a dash times max length plus 1. Yeah, keep missing the plus 1. Yeah, the plus 1 is because of the symbol. Okay. Alright, so what's wrong with this? Oh, because with the symbol itself, oh, so it's actually not, it's not supposed to be like this. It's supposed to be, we should cater this here. So all this is just max length. Which makes our analysis easier, I guess. Okay, so over here, what do they want me to do? Oh, the times must be all the way at the front. Okay, so over here will be OP plus space times, I cannot use rjust anymore, okay, times max length minus length OP plus string B plus string B. Yeah, so the space in the middle I need to manually edit myself. Okay, bitwise n, what is the issue with bitwise n? uh, wow, I need to convert it to binary. Okay, so bitwise all I guess is the same. Yeah, I'll need to convert it to binary. It's not as easy as I thought it is. Yeah, so maybe let's see. Okay, if okay, this is to cater for bitwise operations. This is not easy, you know. This is not easy. Yeah, if OP is in one of the following, uh, N or XOR, okay, if it's one of the following, A equals to binary A, B equals to binary B, and C will be equals to binary C. Okay. Okay, then we take away the OB at the front because we don't need that. Okay, let's try it. So the binary part is only when the number is binary. Very nice. That was tough. This question was tough. Oh, but today, wow, did quite a number of clashes. Oh, so many people. Wasn't easy. Today's clashes weren't easy. Today's clashes were by people who know how to play. Yeah, I think I'll just be playing like maybe about 2 to 3 more clashes before I call it a day. Okay, let's go. Let's go. No time to lose. Fastest mode. Okay, Python is good. Convert number from binary to decimal. I don't get it. All binary digits on the same line, each represented by a word. Also, this is the binary digit. Okay, so okay, so we have a S. Okay, so if each in one of the following one zero yes true, what else, one yes true, one, then s plus equals to one, else s plus equals to zero. Yeah, so it's just a match like that. So print integer s2, that will make it binary. Okay, that was fast. Okay, yeah, so basically it's just to take in all the possible representations of one and zero and then print it out in integer form. Nice. Oh, this is one of the fastest Clash of Codes I've ever played. Okay, let's see, let's see. Okay, reverse mode. I don't really like this puzzle, this ASCII art. This is the top of the head. These are the eyes. This is the nose, and this is the. I guess we just got to do it like, okay, print the hair, then print the, what do you call that? Side, is it? Cheek plus eye plus space plus eye plus cheek. Print cheek plus space plus nose plus space plus cheek. Print cheek. Oh, that was fast. Plus space plus mouth space plus cheek. Print space. Oh, actually, this is chin. So, okay, so the chin needs to be aligned. So, print chin, Python align to center. Dot center. Oh, dot center. Yeah. Oh, okay. It cannot just be centered. There's no space also. Yeah, so strip all the spaces on the right. Yeah, I don't know how he did it so fast. I mean, this problem wasn't that simple to begin with, I feel. Yeah, but oh, he did it really fast. That was amazing. Yeah. Oxido. Yeah, Oxido is really good. Let's take a look. Interesting. The profile pic is purposely taking this, orienting it to the diagonal. Really interesting, really interesting. Yeah, I'm quite interested to see his code, but unfortunately he didn't share it. So, oh, that's too bad for us. shortest mode, so it'll be Ruby. Your program must display every other line of the given text. Display odd lines, and in the second time the even lines. So it's like that. Ooh la la tutu tu fu. So you print these two lines, then the odd lines. Oh, yeah. This if you do this in Ruby, the first time you do it, we just need to take this dot split. Okay, we will get the four options, right? So we could do like that because we don't need the first one. So if we print out L, we'll be getting this. Okay, so we want to print out L for every. Okay, so in order to find out the odd numbers, let's see, how do I do this in the shortest possible way? Yeah, so I guess I need to do something like 0246. I mean, if I were to do the filtering, it'll be 0246, then 135. Yeah, I mean, I can't really do array slicing in Ruby. So that's a downfall of Ruby. That's something that is not that great. So let's do a count thing in Ruby, interval of 2. Let's try to do something like that. Yeah, one way we could do is we could select based on index. Okay, another way is to do a step. I guess we could do a step too. So maybe here we do n. So maybe the first one could be 1 dot n dot to int step 2. Then we can just print out the L like that. Lala Fu. Maybe let's see what's actually print 1 and 3. So Lala and Fu. Yeah, so this is the back part. So if we do a step like that, we could print all this as one thing, and then we could actually we need to repeat this again for the second step. Not sure whether there's a neater way to do it to do this. So in one way is to copy and paste this here, and we start with 2 instead. So start with 0 maybe. Oh, there's a space here. Yeah, so this is a dot dot dot. Apple minus Apple train. Okay, so this is the one that tests whether you know how to split by a new line instead of a space. Yeah, I got 86 characters. Yeah, so it's not exactly that well to use Ruby. Yeah, I guess this problem doesn't really fit Ruby. But look at that, 42 characters. Let's try Python then. Yeah, since Python looks like it can go very short. So later on to take a look. How did he do this? Okay, so actually what we can do is L equals to input for I in int input. Yeah, we could really do this so that int is not iterable. I in 0 times input. So this will repeat it n times. Yes, so we get all this already. Then we can just print out like that. Yeah, so this will be good because we can just do it in one whole line like that. So another way to do it is to just put I equals input here, and then I can just do this here. Just do an I, and then the last one I can even do an as an input prompt. Input takes no keyword arguments in line 3. I guess I will need to put this as input. Sorry, this should be a print. In the end, I didn't really save anything. I must well put this back to input just for legibility. Yeah, okay. I think this is good. Uh, Surprising. How did he do 42? Oxido is really impressive. His number of characters is so low for each of the clashes that he has taken part in. This is what we normally would do. I also did the same thing. This is shorter than the Ruby solution. And yeah, very interesting. Okay, as my last clash, let's do his clash. Zdox clash. Yeah. Oh, I forgot to join. Okay. Well done, Oxido. Yeah, you have stumped me. I have no idea how you got such a short code. It's okay. ASCII art. Oh, this is interesting. It's a binary search kind of thing. What's this at the top? It's a dot, is it? Yeah, it's like a recursive way of producing this. Hmm. I guess we can start with this and iterate from here. Like, no, we cannot. You have to actually take into account where these are. So there's like 0, 4. Oh, this is difficult. This is difficult. This is there like leading space or don't? Oh, there's no leading space also. So let's see. This one is 0, 1, 2, 3, 4, 0, 4, 0, 1, 2, 3, 4, 5, 6, 7, 9. I guess the gap here is like it's going to be the same. This part here is increasing. Hmm. This is actually quite a tough problem for Clash. Yeah, I mean the difficulty is not that I don't know what to do. The difficulty is that there's some sequence that you need to use to solve this, and it's not very obvious what's the sequence. So for each end, we print two lines. I guess the dot at the top is constant. Yeah. Maybe for I in range n, we could print out this pattern already. Print dot space 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 dot. The top is always going to be the same. We can print this, and then we we can do this times n. Then the separation can be a space. Okay, yeah, this looks okay already. Then we can also print the same thing. We can use the same thing here. Okay, I have an extra space. So I'm just printing out the top right now. So this looks good for the top. Yeah, the top is always fixed. Okay, then for the bottom wise, I guess there's a pattern. So this is 1, 2. Over here will be 1, 2, 3, 4, 5, 2, 5. Then this one will be 1, 2, 3, 4, 5, 6. 3, 2, 3, 5, 2, 3, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2, 3, 5, 12. How do I quantify this? So over here we can see there's is multiplied by n over 2. Okay, but the gap here, okay, I got the top correct already. I guess I just need to find the index of this here. This thing up here, the index of this will be this. Okay, let's see. 2, 5. This is 5. It's another 5 plus 1. So it's like 2 times 2 plus 1. Okay, so maybe what we can do is for sorry, 1, 2, 3, 4. Read that 4 times. Okay, range n minus 1. Okay, we print. Okay, this join. Okay, over here, this dash is always the same. Okay, plus this thing here is a function of my n. So counts equals to 1. Okay, so for a range in this, okay, so after I do the first one, I increment my count equals to count times 2 plus 1. Yeah, over here my count is 1, but here it's just times 2 plus 1. 1, 2, 5. I guess from here on it's always going to be times 2, 11. This one is 11. Yeah, so the first line, looks like the first line is an exception, but from here on it will always be times 2 plus 1. So let's just print out the first line. Okay, so over here we print out count will start with 2, and then count times 2 plus 1 all the way. So this one times counts plus space plus this one times count plus this one. And over here, how many do we need to print this out? 1, 2, 3, 4, 5, 6. Look at that. Yeah, he's really good. Yeah. So we start with number is to the power 4. So times number, print this out. And then over here, even this space over here, right? We need to actually exercise some caution. Yeah, because this space is actually, oh, actually I found the pattern already. This space is 1, 2, 3, 4, 5. This space is 5, which is the same as this count times 2 plus 1. So the first one is 2 to the power of n. This one is also 2 to the power of n. Then the second layer, there's an offset here. This offset is 2. This offset is also actually the count. Very nice. Okay, so I have actually extra here. So because I didn't do my number. Can't multiply sequence. That's weird. Oh, because it's a float, so I need to do law divide. Okay, so I think I'm almost done. Okay, I kind of feel like I'm missing something. So test 4 is kind of feel like I have more than necessary. 1, 2, 3, 4, 5, 6, 7, 8. 2 to the power 4 is 2 times. Actually, it's not 2 to the power of n. It's actually 2 times the number, because it's always divided by 2 here. So the top layer is 8. No, this is 4. So it's 2 times 2. Maybe it's 2 to the power of n minus 1, maybe, instead of 2 to the power of n. Okay, let's see again. This one. So for test 2, so over here should start with 2 to the power of n minus 2 then. Very nice. Okay, then at the end I need to sum up the last one. So 1, 2, 3, 4, 5. So we just print count plus this. Wow, this was sure this was tough. This was one of the toughest clash I've ever played. It's not easy at all. Let's see. Finally he shared his code. This guy is a genius. Look at that. Look at that. He already solved all this already. The R strip ls equals to 2 to the power of n minus I minus 1 minus I. Yeah, that's correct. Okay. We stripped out the space edit right here. Because over here he used this formula times k plus this times k plus length plus this one plus times k plus this times k. Actually, he could just like take away this, right? Yeah. L equals to s times 2 to the power. Oh, he needed this. Yeah, this one is yeah, and then he R strip to remove the space at the back. Yeah, very similar to my code. I kind of like his code actually. Yeah, but the thing is, Oxido is really someone quite he just wanted to print out one. Yeah, Oxido is really someone quite good in Clash of Code. Yeah, I really think that this is something that is not easy. This problem, and yeah, it was fun playing with him. Okay, I've got to go. Yeah, thanks for watching the stream and see ya.